In this video, we're going to talk about how to describe transformations of rational functions. So remember, the rational parent function has a vertical asymptote at x equals 0, like we discussed in the previous video. And remember, the domain is going to be in two pieces. We have a piece that comes from negative infinity to 0, and a piece that goes from 0 to positive infinity. The horizontal asymptote will be at y equals 0. Remember, the range is going to go from negative infinity to 0 for the first piece, and then it's going to go from 0 to positive infinity for the second piece. So the parent function is 1 over x, and then all other rational functions will represent transformations of this original parent function. The transformed functions will all have the form a over x minus h plus k, where a, h, and k represent constants. So remember, the three types of transformations we'll talk about are shifts, which are translations, stretches or compressions, and reflections. So remember, a is going to be a vertical stretch if the absolute value of a is greater than 1, and it's going to be a vertical compression if the absolute value of a is between 0 and 1. If a is less than 0, that's going to represent a reflection over the horizontal asymptote of the function. It's going to be shifted to the left if we have x plus h in the denominator, and shifted to the right if we have x minus h in the denominator. It's going to be shifted up when k is a plus k value, and then it's going to be down when we have a minus k. So let's look at an example. It says the function f of x equals 1 over x is transformed to g of x equals 1 over x plus 4 minus 2. Let's describe the transformations. So I'm going to use my highlighter and see what changed in this new function. So I have a x plus 4, and I also have this minus 2. So if I study that x plus 4, and I go to my chart right here, you can see that that is a shift left when I have an x plus h in that denominator. So that means that this x plus 4 is going to have the effect of shifting the function left 4 units. Okay, so now the next thing I have is that minus 2. So if I go to my study guide, I can see that that minus 2 is a minus k value. So that means I'm going to have a shift down when I have a minus k. So that means that function is going to go down 2 units. So now let's make sure that we've done this correctly by going to Desmos and typing in the parent function. So we have 1 over x. Here we do over x plus 4, and then we click outside that fraction and do minus 2. So it's kind of hard to see with rational functions, so you may have to zoom out a little bit, but you can see that in fact this red function is shifted to the left, and also it is shifted down when you compare it to the original parent function, which is here in purple. So now let's go ahead and study this transformation. So we have f of x equals 1 over x transformed to g of x equals negative 3 over x minus 2 plus 1. So we have this negative here in front, and we also have a 3. So that's actually going to represent the value of a. So I know it's hard to see the way it's written, but you kind of want to think about this as being like g of x equals negative 3 over x minus 2 plus 1. Okay, so just go ahead and think about that negative as being with the 3. So that means that represents a transformation of A. The absolute value of negative 3 is 3, which is bigger than 1. So that's going to be a vertical stretch. And also, since that 3 is negative, that's going to be a reflection. Negative 3 being a vertical stretch. And also, we're going to have a reflection over the horizontal asymptote. Okay, so now let's think about what else is transformed here. So we have an x minus 2. So if we go to our chart, it says that there is a shift right when we have an x minus h. So x minus 2 is going to create a shift right 3 units. And then finally, on the outside of this function, we have this plus 1. The plus 1 is going to represent a shift up because that is a plus k value. So we can say that this graph has gone up 1 unit. Okay, so we can graph this new function along with the parent function in Desmos to see what it looks like. So we have negative 3 over x minus 2, and then we click outside that and do plus 1. So you see how the graph has been reflected. Also, you see that this has been shifted to the right 3 units and also shifted up 1 unit. So now you can go ahead and pause the video and try doing this example on your own. So here we have a minus 3 in our new equation. Remember that minus 3 is going to be a shift down because that's a minus k value. So if we go ahead and look at the graph, you can see that compared to the original parent function in blue, the green graph is shifted down 3 units. So now let's go ahead and write equations given transformations. So it says f of x equals 1 over x is shifted left 3 units and then up 5 units to form g of x. So remember, left 3 units, if we look at our chart, it says left when we have x plus h. So that means that we're going to say this will be an x plus h. And the effect of that is going to be that we have an x plus 3 because it's shifted left 3. Then we have an up 5 units. If we look at our chart, we can see that up 5 is when k is positive. So we're going to go ahead and say that plus k is going to be a plus 5 value. So if we now write our function, we're going to have g of x equals 1 over x plus 3, and then this plus 5 is going to go on the outside. Let's go ahead and graph the transform function to see that that is in fact what happens. Let's do 1 over x plus 3, then click outside that and do plus 5. So you can see the graph has been shifted to the left 3 units and up 5 units to form g of x. So now you can go ahead and pause the video and try doing this example on your own. So here it says that the function is vertically stretched by 4 and shifted right 1 unit to form g of x. A vertical stretch by 4 means that a is greater than 1. Shifted right 1 means we have an x minus h situation. So we are going to have g of x equals 4 over x minus 1. If we go to Desmos and we look at the graph, you can see the new transform function in green is stretched out, and also it is shifted to the right 1 unit. So remember, you can study the values of a, h, and k in a rational function to determine the transformations on the graph. A will create a stretch, compression, or reflection, h will cause a shift left or right, and k will cause a shift up or down.